This is like part 2 of what I couldn't finish, but in mechanics we were doing a little bit complex stuff about accelerations and velocity and displacement and all of that. It was basically comparing like the formula that we know to like graph, and like in graph in a way that we're looking for the integral, like not the integral, the derivative, like the instantaneous velocity or the instantaneous acceleration. So then if it's a velocity time graph, then we could find the instantaneous acceleration where basically the time approaches zero. As the time approaches zero, the acceleration approaches the instantaneous one. And same thing for the velocity in the displacement time graph as time approaches zero. Another concept is that when there's a trajectory instead of like a straight line, like a trajectory when there's a gravity, let's say, and it's like making an arc, you always want to add or manipulate whatever it is, the accelerations components by components to the components of velocity, the components of the displacement itself. You don't want to be adding it up, like using x and y's together. It's just x in acceleration with the x in velocity, the x in y in velocity with y in displacement, whichever it is. You always work by components, and yeah, that's like the basic concept for today's class. Other than that, there is the acceleration that, depending on where the orientation is for the acceleration, the velocity changes accordingly. So if the acceleration is perpendicular to the velocity, then the speed, or you could say the magnitude of the speed, does not change. The magnitude of velocity does not change, and only the direction changes. So basically towards where the acceleration is facing, which is 90 degrees from the velocity that we're talking about. If acceleration is parallel to velocity, then in this case it will either add magnitude or take away magnitude. So it will get either faster, speedier, or slower, obviously. And then if there's a little bit of angle, then that's where x and y's comes in play. You have to accordingly adjust the x and the y's, and then depending on that, it will change where, or towards where, and towards which angle the trajectory will look like. And important stuff here is to know how to add vectors, because you have to understand that when we're talking about velocity especially, the acceleration has an orientation that is the same as the delta v, or the delta velocity. So yeah, that's something we learned today.